Good afternoon, everyone. Yes, I'm here today representing Surrey Satellite Technology in the United Kingdom. I'm going to talk to you about Lunar Pathfinder, which is our upcoming communications relay satellite. So a bit of background, a rejuvenated interest in returning to the moon has unlocked this emerging lunar economy with bullish forecasts of revenues in the hundreds of billions over the next sort of couple of decades. And this sentiment is being matched by record levels of government funding towards space exploration, which is a trend that's expected to continue into the next decade as well. So to build our business case for Lunar Pathfinder, we conducted a number of internal analyses and identified some trends. So we see a slow increase in the number of missions increasing year on year, driven by successful lunar landings, more regular lunar transport opportunities, and a maturing lunar infrastructure, which will augment additional services off the back of these. In terms of mission types, we're seeing a high volume of CubeSat missions due to their sort of low cost and ability to be used as of both rovers and landers due to their utility for both crewed and non-crewed missions. In terms of data, we're looking at growing data requirement demands, really jumping within the next decade and just continuing into the 2040s, driven by more capable technologies in terms of data rate and data volumes, more durable technologies due to the ability to survive lunar nights, and more ambitious missions such as in situ resource utilization or surface stations, which will be naturally more data hungry. In terms of locations, great focus on South Pole and far side regions due to their sites of scientific significance, and also the detection of a relative abundance of resources like water and other volatiles, which can be used for the long-term sustainability of the moon. So we've identified an emerging lunar economy. Why do we need data relay? Why can't we just use sort of the incumbent solution of direct Earth communications? When we consider DTE as an independent solution, a few challenges arise. The first one being line of sight. So direct Earth requires a direct line of sight between the Earth ground station and the spacecraft or lunar asset that they want to communicate with. This is impossible on the far side of the moon. It's limited at the polar surfaces, which we've seen as a hotspot of activity, and can be affected by lunar topography like ridges or craters. Another challenge that arises is in terms of availability of the direct Earth networks. And this growth in missions over the last few years, and which is expected to grow, has resulted in these networks being routinely oversubscribed, and this is only likely to sort of continue. Our third point here is to do with flexibility. So user requirements, depending on the mission phase, will be completely different. If you think about a lunar lander during orbit operations, their usage of a communication service can go from minimal compared to when they're during descent and landing, where they will be completely different. Trying to accommodate this flexibility in DTE network schedules, which are often scheduled weeks to months in advance, can be very difficult. Additional benefits can also be delivered through data relay, including reduced operational costs by optimizing the use of ground stations, lower swap property terminals that, versus those that are required for direct to Earth. Communication performance can also be enhanced, such as improved data rate or increased data volume versus those that are achievable through direct to Earth. Using something like Lunar Pathfinder as a secondary solution will help to retire some risk by using it as redundancy. So helps to sort of de-risk some of these missions that operate in the lunar environment. A data relay will also solve the line of sight issue that I talked about in the previous slide, which will improve the exploration capability of something like a lunar rover, which can go to the far side. It can go outside of the proximity of its lander. It can go into craters. So just really increasing that exploration proximity and value from the mission. And last but not least, we have interoperability, so flexible integration with the rest of the lunar ecosystem to really maximize the impact from missions. So Lunar Pathfinder is due to launch at the end of 2025, with services beginning in early 26 after a short commissioning period. due to last for around 8 years of operational lifetime. Lunar Pathfinder will operate in elliptical lunar frozen orbit, or LFO. This is really to focus on a long duration coverage of the South Pole, which, as we've identified, will be a hotspot of lunar activity. SSTL will also be partnering with the ground segment provider KSAT in order to kind of combine the strengths of both direct-to-Earth and lunar data relay to really leverage the strengths of both of these solutions. So we have some very exciting news this year. We found out who will be delivering Lunar Pathfinder to its orbit. So through NASA's CLIPS CS3 task order, Firefly Aerospace will be delivering Pathfinder to its orbit using their Blue Ghost lander. So once Pathfinder's been deployed, Blue Ghost will then land on the far side of the moon, and one of the hosted payloads on board, Lucy Knight, which is a NASA radio telescope on the far side of the moon, will begin its operations, and Lunar Pathfinder will actually serve Lucy Knight with these data relay capabilities. So Lunar Pathfinder will communicate with assets through the Moonlink in S-band using a proximity 1 protocol, which allows it to communicate with a number of different assets within the same coverage area. This data will then be relayed back to Earth in X-band. In order to maximize the scientific output of Lunar Pathfinder, there will also be a number of hosted payloads on board from a couple different institutional partners. So NASA will provide the laser retroreflector, which will be used to carry out ranging experiments to inform future lunar missions. A GNSS weak signal detector from the European Space Agency will allow us to investigate the potential of Earth GNSS signals to be used to augment lunar navigation. And our third hosted payload is also from ESA, and this will be a radiation monitor. So we will be investigating the characteristics, the radiation characteristics of the orbit of Lunar Pathfinder. So in terms of our service portfolio, we kind of have two boxes here. So if you think if we're looking at the middle and the last box, we'll see baseline services, which will be provided as soon as Lunar Pathfinder becomes operational, and our future development services, which will be implemented somewhere down the line of Lunar Pathfinder's lifetime. So all the communication services will work on a store and forward architecture. If we look at our first one, our autonomous service will allow the contact between Lunar Pathfinder and the customer asset to be automated, allowing the capacity of Lunar Pathfinder to be optimized. Our schedule service is for those who are looking at more dedicated offerings, so they can decide on the time and the length of the contact. Pathfinder can also be retasked in the event of an emergency in order to assist some assets in a state of stress. So down the line, we're looking to implement our expedited data transport service. It will be the highest level of performance, lowest level of latency. Backup service will be for those where Pathfinder is maybe the secondary communication solution, so talking about earlier retiring some of that risk. And point-to-point, which will allow a lunar asset to communicate with another lunar asset through Pathfinder, so no need to involve an Earth ground station. And to just catch you up quickly on some of our activities, so we have a mission builder app, which is available online. Potential users can input high-level mission characteristics and receive a forecasted coverage and performance report. Our service guide is also available online, so it just delves into deeper detail about some of the services that I've talked about today. And just a note on Lunar Pathfinder's namesake. So it's actually gained this from being the first node in what will be ESA's Moonlight initiative. So Moonlight will be a constellation of lunar orbiting satellites that will provide enhanced communication performance and navigation services as well. So very exciting times to be involved in this space. Thank you all for listening. And please get in touch if any of this sounds interesting to you.